Alright guys, this is our second lesson for multiplication. I want to do a quick review. If 3 times 4 equals 12 is the equation, keep in mind that these two numbers we're multiplying together are our factors, and the answer or total is our product or count by. Okay, the other word I want to introduce is multiplier. Multiplier is simply the number you're multiplying by. So in this example, 9 times 1, 9 times 2, 9 times 3, and 9 times 4. I'm multiplying 9 by 1, 2, 3, and 4. So these numbers are known as my multiplier. It's what I'm multiplying 9 by, okay? Alright, array. This is how we're going to start to look at some of our multiplication problems. We've already done repeated groups and equal shares, and now we're going to talk about an array. Array is simply an arrangement, okay? It can be of numbers, it can be shapes, it could be dots, anything. What you need to know about an array, though, is that there's a specific way we have to write the equation. Okay, there are what we call rows. Rows go across or horizontal like this. This is row 1, row 2, 3, and so on. Okay, and then we have columns. Columns go up and down. We have 1, 2, 3 columns. One way you could think about it is rows. You could think about when you go into the big auditorium at the school, we have rows of chairs. They're going along. In our classroom, our desks are in rows. Okay, they go across the room. Columns, you could think of, maybe you've seen a house or the Capitol building, and they have big columns, okay, big circular cylinder columns. They go up and down the building. That's another way to kind of remember it. So the way I'm going to write this is rows come first, so 5 rows times 3 columns. Okay, and if I count up all my dots, I'll get 15. One way that I always like to remember it is you have to row your boat before you can go down the stream. So you have to row across before you can go down the stream. So rows before columns. Alright, and now also there's a commutative property of multiplication. If you think back to the first few weeks of school, we talked about the commutative property of addition. And this just states it does not matter the order of these numbers, you're going to get the same outcome. Okay, so 3 plus 2 equals 5, just like 2 plus 3 equals 5. So the order in which I put these numbers does not matter. I will still get the same outcome, in this case the same sum. When we look at multiplication, it's the same thing. 4 times 2 equals 8. Okay, and I showed you all 3 ways. I showed you the equal shares, I showed you 4 groups of 2, and I also showed you the array, 4 rows of 2 equals 8. Now if I reverse the order of my factors and put 2 first, 2 times 4 equals 8, I get the same thing. The drawings just look different. Now I only have 2 groups of 4, or 2 rows of 4 columns. Okay, notice the difference in these drawings. Because the rows come first, your drawings look very different. Alright, let's do some practicing. So here's an example of an array, and I want to know how many stars. Okay? Now, yes, you can count and see that there are 6, but you need to be able to write the multiplication equation. So again, to remind you, first I need to count my rows, 1, 2, 3. So 3 times my columns, 1, 2. And then you count them and you get 6. Another example, how many squares? Okay, I'm going to row my boat across. I have 1, 2 rows, and I have 5 columns in my stream here. So row your boat, go down the stream. 2 times 5 is 10. Okay, you count up your squares to find your answer right now. Alright, now let's look at this example. Sam put his trophies on a shelf, arranging them in 6 rows of 3. Well, I know that the 3 is telling me columns. How many trophies does Sam have? Well, here's one way you could do it. I'm going to draw 6 rows. 1 row, 2 rows, 3 rows, 4 rows, 5 rows, and 6 rows. Okay? And it says 6 rows of 3. So I know that in each row I'm going to have 3 trophies. Okay, so now this is looking like an array, right? So my equation for this would be 6 rows times 3 in each row, or 3 columns. And if I count up each circle, I will get 18. So he has 18 trophies. All right, let's do another example similar to that other one. Still talking about Sam. Sam bought a box of markers that had 3 rows with 10 markers in each row. Okay, so in this word problem, it kind of helped explain what that meant. It helped tell me 10 in each row. How many markers did Sam buy? Well, again, I can draw my rows. 1 row, 2 rows, and 3 rows. And now I know that he has 10 markers in each row. So you could do this and actually draw out 10 circles, or, well, yes, let's do that since we're doing arrays. To speed up the process later, you could just write the number 10 and count by tens, but let's do this to stick with 5, 6, 7, 8, 9, 10, the way we just did the other problem. Okay, so each row is going to get 10 markers. It's really hard to do this and talk. You should try to draw these and talk. It's hard. 4, 5, 6, 7, 8, 9, 10. All right. So now I have my 3 rows. Remember, that comes first by my columns, and I'm going to have 10 columns. So 3 times 10, and if I count all of these, I would get 30. Okay, so 30 markers is what Sam bought. All right, lastly, the commutative property. I want us to look at this. If I wanted to write first the equation of this array, I need to count my rows first. So 1, 2, 3, 4 rows times my columns. 1, 2, 3, 4, 5. Okay? And if I count all of these, I would get 20. So how can I draw this another way to show the commutative property? Well, I just want to reverse the order of these because that's what the commutative property says. It says the order of these factors do not matter. I will still get the same product or answer. So now I want to draw 5 rows because remember that comes first. So 1, 2 rows, 3 rows, 4 rows. 5 rows, and then I'd like to draw 4 in each of these. So 1, 2, 3, 4, 2, 3, 4. All right, so now my drawing looks similar but different. Okay, now I have 5 rows and 4 in each row versus 4 rows with 5 in each row. Okay, so do you see the difference? And I hope that you understand that the order of these factors do not matter. I still have the same product. All right, here comes your fun part, homework. Only have 3 problems, okay? So if you need to go back to rewatch any of these examples or things that we did, do so, and then give this a try. I'd like for you to write the equation of this array, how many hearts, okay, rows, then columns. Then this problem, Mr. Bond set up 6 rows of chairs with 8 chairs in each row. How many chairs did he set up? I want you to draw an array to help you, and I'd like the equation as well. So just like the other 2 problems we just did. And then lastly, I want you to look at this array. It's 3 times 2 equals 6. And I want you to show me another way. So draw that array another way using the commutative property to help you. Okay? So prove the commutative property by drawing this array in the other way. Okay? Again, we just did an example, so if that's unclear, go back and watch the example. All right, good luck, guys.